Hi, my name is Gavin Walker. I'm from the JBS Law Magnet. This is free response question number 4 from 2013 AB1. Question gives us on a certain workday the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T equals 90 plus 45 cosine T squared, where T is measured in hours, 0 and 8 at the beginning of the workday. T equals 0. The plant has 500 tons of unprocessed gravel. During the hours of operation, 0 and 8 hours, the plant processes gravel at a constant rate of 100 tons per hour. Question A asks us to find G prime of 5. So all we got to do is click it in a calculator, math 8, or it's asking us to find G prime of 5, and then interpret the answer in the context of the problem. So just choose your variable. I prefer A. Then type in the equation, 90 plus 45 cosine fraction cosine x squared over 18, and then when executed when x equals 5. So you enter that there, and then you're going to get negative 24. Okay, so now this is where, so you're going to want to put G prime of 5 equals negative 24.588. Then this is going to be interpreted as at time equals 5, the rate at which gravel is being processed is decreasing by 24.588 tons. And that's A. B says find the critical point of G of T and interpret the significance of this point in the context of this problem. B, okay, so in order to find B, we just need to take the derivative of G of T, and that would be G prime of T equals, negative 5 T times sine T squared all over 18 over 18. Okay, and then from there we just factor it out and get the critical number. So x equals, or well, t equals 0 and t equals 7.5198848. You can find that by plugging it into the calculator. So then afterwards you would make a, or you know what, it'd be better to plug it into the calculator. So you would plug in the original equation into the calculator. So then that would be 90 plus 45 cosine plus 45 cosine x squared all over 18, and then also be sure to type in the equation, the derivative. So that would be negative 5x negative 5x sine b squared over 18. Then you're really going to want to mainly pay attention to the red graph when it pops up, because that's the graph that's going to help you determine the significance of the critical points. Okay, so okay. So then with that, you just kind of look at the graph and kind of analyze it a little bit, and then should come to the conclusion that at time equals 7.51988848, the amount of gravel of gravel being processed changes from positive at t, oh well, hold on a second, it's at t equals 7 point, or, oh my bad, oh yeah, t equals 7.5193, and then t equals 0, and t equals, calculate 2. And t equals negative 7.51988848. The amount of gravel processed so at t equals 7.5198848 and negative 7.5198848, the amount changes from negative to positive. To positive, and at time equals 0 changes from positive to negative. Okay, and that's B. So now C. C says write an equation for the line tangent to G of T at the point 5, 9, 8, 5 and 9, 8, 1, 4, 1, using the tangent line to approximate. So all you gotta do is just plug it into like a tangent equation. You already have everything you need. You found out your slope right here at 5, and then all you just need to do is plug in the points of the tangent equation. So y minus 98.141 equals negative 24.588 times x minus 5. And from there, you want to get y on one side, so add 98.141 to both sides, and you're going to get y equals negative 24.588 plus 221. A second, 24.588 times 5. And then you're going to plus 98.141, and you're going to be getting 22.1.081. And then once you get that, you just need to plug in the 5.5. Y equals negative 24.588 to 5.5 plus 221.081. So multiply 24.588 times 5.5, and then subtract that from the other one. Then you're gonna end up getting 85.847. And then that's gonna be to approximate 5. And then that's all there is to it. Make sure you put the approximation signs. So that's all for C. For D, it's asking you, given that G double prime of 5 equals 7.430, it's asking you, does your tangent line approximation in part B over or underestimate 5.5? So we just need to really look back at our answer and just decide what it is. So it's an over approximation. Okay, and that's all there is to it for D. Now for E. For E, you gotta. E is saying, based on the information found or given so far, determine which of the following statements are true about G of T at T equals 5. So we just really need to look at our handy dandy graph. Handy dandy graph. And then again, readjust. Ooh, that might have been too much. Okay, that's all. That's all for now. So we let me see. We kind of want to fix it a little bit so that way we can get it back at 5. So negative, we're going to put it at 0, and then the x max we're going to put it at 6, and then we're going to graph it. So as you can kind of see there, at G of 5, it looks like it's concave down. I'm going to zoom out just a little bit just to check. Oh my. Oh crap. Negative 5. Sorry about that. So let's try to regraph that. Negative 0.05. Okay, there we go. Or you know what? Let's make our window just our Y max just a little bit bigger. 10, 150. So make sure you pay attention. 3, 4. See how it's decreasing and concave down at G of 5. So we know 4 is right. And we know it's not increasing at all. Oh wait, no, never mind. So it's not 4. It's not. We know it's not increasing at all, and it's not increasing at an increasing rate. So we know it's gonna be. Hold on a second. Increasing, decreasing. Okay, so we know. So the answer is going to be 3, because it's decreasing at a decreasing rate, I believe, because you see right there it's concave down, so that means it's a decreasing rate, and then it's also decreasing itself. So the answer would be 3, because concave down, and decreasing. Thank you. There'll be a part 2 to this question, and we'll see you then.